By the end of this lesson, the learner will be able to explain the elements of true precision cooking, describe the science behind a perfect egg, and incorporate the perfect egg technique into a modern recipe. Precision cooking is a method in which you control precisely the temperature in which food is cooked. It allows us to get the point of protein and fat transformation, how cooked it is, to be very specific, not overcooked and not undercooked. Since molecular transformation is very specific with temperature, you can also keep the food longer in that state without losing quality. Normally, it's achieved with the use of a water bath or precisely controlled water heater known as an immersion circulator. You put the food in a sealed container, usually sous vide, and submerge it for the desired time. The reason we can be very precise with the temperature of cooking in this method is because water is the best liquid for heat transfer. To demonstrate the precise capabilities of the immersion circulator, we can cook 2 eggs. One whose core temperature reaches 63 degrees, and a second that goes half a degree higher to 63.5 degrees Celsius. The first egg is soft boiled and has a white which holds and a runny yolk. The second egg, we can see as we pull away the soft white shell, has a yolk with the texture of very loose Play-Doh, or pâte à modeler as it is called. This will also happen if we cook the egg to the perfect 63.2 degrees, but for 90 minutes instead of 45. The texture is very different than that of an overcooked egg yolk. This is a style of cooking known as sous vide, which involves heating things under vacuum, or in the case of eggs, in the shell, at specific temperatures. There's a belief that when you cook an egg sous vide, once the water reaches the temperature you are interested in, it doesn't matter how long you cook it for. But this is not true. When an egg is cooked, the proteins in the yolk unravel, a process known as denaturation. Proteins can be denatured by strong chemicals, such as acids, by mechanical action, or through heat, which is the case of the 63.2 degree egg, the perfect egg, discovered by Dr. Bruno Gusseau. There's a false notion, even among scientists, that proteins have definitive, discrete denaturation temperatures. The belief is 67 degrees Celsius is the temperature at which egg yolk proteins start to coagulate. But it depends on the thermal history of the egg. I can heat it at 35 degrees Celsius, and if I wait long enough, it will denature it. Boiling the egg denatures it too, but it happens so fast that the textural outcome is different. Some proteins in the egg yolk denature at higher temperatures than others, and more proteins denature the longer the egg is cooked. The hotter the temperature and the longer the cooking time, the more viscous the yolk becomes. And the science of cooking eggs extends to other foods too, such as meringues, which are made from whipped egg whites and sugar. Cream of tartar or lemon juice are often added to meringues. But why? It has to do with the degree of acidity. Egg whites are slightly basic or alkaline, which makes the proteins clump together when they're whipped, causing the foam to collapse. Cream of tartar and lemon juice are both acidic, so adding them to egg whites neutralizes them and they don't clump up as much. You can whip and whip and whip and the egg whites won't mind. The spring eggs, hot spring eggs, or onsen tamago as they are called in Japanese. A traditional low temperature egg which is originally slow cooked in the water of hot springs in Japan. The egg has a unique texture where the white tastes like a delicate custard, milky and soft, and the yolk comes out firm but retains the color and creamy texture of an uncooked yolk. This special texture is the result as egg yolk and egg whites solidify at different temperatures. The egg is poached within the shell and is served with the shell removed in a small cup with sauce of broth and soy sauce. The traditional way of cooking onsen tamago is to place eggs into rope nets and leave them in a hot spring with water that is approximately 70 degrees Celsius for 30 to 40 minutes. Crack open the shell and serve the egg in seasoned bonito dashi, which is a Japanese stock, for breakfast, or in a light sauce made with mirin, dashi, and soy sauce with chopped spring onions sprinkled over the top. The 100-year-old egg, also known as preserved egg and black egg, is a Chinese preserved food product and delicacy made by preserving duck, chicken, or quail eggs in a mixture of clay, ash, and salt for several weeks to several months, depending on the method of processing. Through this process, the yolk becomes a dark green to gray color with a creamy consistency and strong flavor due to the hydrogen sulfide and ammonia present, while the white becomes a dark brown, translucent jelly with a salty flavor. The transforming agent in this egg is an alkaline salt, which gradually raises the pH of the egg to around 9 to 12. This chemical process breaks down some of the complex, flavorless proteins and fats and produces a variety of smaller, more flavorful compounds. Next time you are soaking in the hot springs in Japan, reach down to see if there are any perfect eggs. Are you brave enough to try the 100-year-old egg?